Good morning, students. Today we will study last part of this chapter, that is alcohol, phenol and ether. From this chapter we will study today ethers. First point given in this chapter is to study preparation of ethers. So there are two methods given for the preparation of ethers. One of the method is dehydration of alcohols. So we had already studied this dehydration of alcohols in alcohol part of this chapter. So when alcohol is dehydrated using concentrated H2SO4 or concentrated H3PO4, then two products are possible, and this depends upon the conditions, mainly temperature condition used in the reaction. For example, if we carry out this dehydration of alcohol, then two molecules of this alcohol take part in the reaction. This reaction takes place in the presence of concentrated H2SO4 at 413 Kelvin. Then we get ethoxyethane, that is a diethyl ether. But if the temperature condition is changed to 443 Kelvin, then instead of ether, we will get ethene. So that is the difference in the temperature condition for this reaction. So this reaction is given here. Here, this ethyl alcohol molecule, when heated with concentrated H2SO4 at 443 Kelvin, then we get alkene. So both are dehydration reaction. Remember well that for the preparation of ether, temperature condition used is, it is 413 Kelvin and not 443 Kelvin. If we use 413 Kelvin, then we get ether as a product. And if we use the temperature condition as 443 Kelvin for the same reaction, then we get alkene here. So in this method, mainly symmetrical ethers are prepared. Symmetrical ether means either side of this functional group oxygen contains the same alkyl groups, and mainly from this method primary alcohols are used for the preparation of ether. So that is the first method for the preparation of ether. Then second method for the preparation of ether is a well-known method called as a Williamson's synthesis. This method is used for preparation of simple as well as mixed ethers. Then in this method, alkyl halide is treated with sodium alkoxide or sodium phenoxide. Then it gives dialkyl ether or alkyl aryl ether. Both general equations are given here. Rx is alkyl halide. When treated with sodium alkoxide, then we get this ROR plus NX as a side product. ROR is ether. Then Rx, that is alkyl halide, treated with this sodium alkoxide of phenol. So it gives, that is a sodium phenoxide, and it gives the ether containing one alkyl group and one aryl group. Side product is sodium halide. So this reaction follows SN2 type of mechanism. Here ether is formed as a result of backside attack by alkoxide or phenoxide ion on alkyl halide. This is given here. So sodium alkoxide, this is a tertiary. When attacks on this methyl bromide, this is a primary. Here backside attack take place, that is it follows SN2 mechanism. Here alkyl halide used, that must be primary. Alkyl halide used, that must be primary. If this alkyl halide used is tertiary, then instead of getting ether, we get alkene as a product. And therefore, this alkyl halide used in this reaction is primary. And this sodium tertiary butoxide can be used along with this primary alkyl halide. Equation is, this is a sodium tertiary butoxide attacks on methyl bromide. This is a primary alkyl halide. This is a backside attack, that is attack take place opposite to this leaving group, that is the bromine group, and the formation of ether take place. Here this ether is tertiary butyl methyl ether. Side product is sodium bromide. So this is preparation of ether by using Williamson's synthesis. Now, if we had studied now, alkyl halide used here is, it is a primary, and alkoxide, that is a tertiary. In opposite way, if you use alkyl halide as a tertiary, then as I had told you that instead of ether we get alkene as a product, that is a isobutene here, and other product is ethanol and sodium chloride. So if secondary or tertiary alkyl halides are used, then it leads to mainly alkene formation, that is the elimination reaction take place. So to avoid this elimination reaction in Williamson's synthesis, alkyl halide must be primary and not tertiary. So that is about the preparation methods of ether. We had studied two methods. One is from alcohol and second is from Williamson synthesis, that is by using alkyl halide. That is about the preparation methods of ethers. Thank you.